Hello, this is Math with Beth, and we're going to look at some properties of definite integrals. The first one is the additive property. So this one's pretty self-explanatory. If you're looking at three x values, A, C, and B, and if C is in between A and B, then if it would be helpful, if you want the area between A and B, you could split it up and find this area and this area and add them together. Okay, so let's just see why that would be helpful. So for the area under the graph of f from -4 to 5, it's this piecewise function, which means when x is less than 3, it's y equals 9. But when x is greater than or equal to 3, it's a different function, y equals x squared. So this would be a reason why it'd be helpful to split it up. So if we wanted to know the area between -4 and 5, I'm going to first do -4 to 3, because then I can use the first function for that. And then from 3 to 5, I will use the second function because that is where they are existing. So now I can do these separately. So hopefully you've already learned about definite integrals, where we're going to do the antiderivative. And we'll plug in 3 and then subtract what we get when we plug in -4. And over here, the derivative, I'll use the power rule, which means I'm going to add 1 and divide by that same number. And I'm going to do that by plugging in 5 and 3 and subtracting. So we end up getting 9 times 3 minus 9 times -4 over here. Over here, we get 1/3, 5 to the third, minus 1/3, 3 to the third. So if you do all that correctly, you end up getting 95 and 2/3. So that would be the area, and we got that by splitting it up and then adding those together. Okay, for the next property, we're going to learn how to find the area between two graphs. So this time we have two different functions, and we're going to find the area in between them. So here is the rule. And you just need to make sure that this is your top function and this is the bottom one. So if you're not sure, you definitely should graph and figure it out. So in this case, f is on top. So if I wanted this area in between f and g from a to b, this is what I would do. F of x minus g of x and do the definite integral. So let's do an example. Find the area grafted or bounded by the graphs of f of x equaling to x plus 1 and g of x equaling to x squared plus 1. So first I'm going to graph so I can see what it is I'm looking at. So the first graph's just a line. So hopefully everyone can graph that. You start at 1 up 2 over 1 because that's the slope. And you could also go down to left 1. And so our first graph is a line, but then the second graph is a parabola that would start at 1 and go up. So the pattern is over 1, up 1, over 2, up 4. So I think we'd end up getting a picture like this that we're trying to find the area in between. So if you aren't sure, which my graph's not perfect, so I'm going to say I'm not sure exactly where these 2 points are. I'm just going to find out really quickly by setting the 2 equations equal just to double check where they are intersecting. So if I set these equal, I would end up wanting to get everything on one side. So I would subtract the 2x. I would subtract the 1. That would wipe out that 1. Then I would factor, and I can factor by taking out an x, and then I would split these up to solve. So I end up getting x equals 0 and x equals 2. So just to double check, because that's not exactly what this looked like, so that helps. So I know I'm going to do the area between 0 and 2, and I can clearly see that the top function was the line. So that's what I'm going to do first, minus the parabola. So that is what I need to find the derivative of, or the antiderivative of, so I can do my definite integral. So first I'm just going to make this nicer. I'm just going to reduce inside there before I do any real work. So I'm going to put it in order. Again, the ones ended up wiping out. So I only really have to do the antiderivative of this. So that would give me negative x to the third divided by 3 plus 2x to the second divided by 2. So that 2 over 2 wipes out. And I'm going to do this from 2 to 0, meaning I'm going to plug in 2 first and then subtract what I get when I plug in 0. So negative 1/3 plugging in 2 would give me this, minus plugging in 0 into all of that would just give me 0. So I really only have to figure out what that is. And that is 4/3. So that would be the area between these two functions. So you just have to make sure you know where you're looking. So in this case, they didn't tell me to look between 0 and 2. So I had to use the graph to figure out and set them equal to each other to figure out I was going between 0 and 2. And I needed to know which graph was the top one. So I could do the top minus the bottom. Okay, average value. The definition is for f, a continuous function over a to b, the average value, y_av is what they're calling that, is given by this equation here. So when they ask you for an average value, this is the equation we're going to use. So here's an example. Find the average value of f of x equals x squared from 0 to 2. So this time they did give us the interval 0 to 2. So according to this formula, the extra step is that out front, I'm going to do 1 over b minus a, then the integral of the function. So this is really the only extra step for finding the average value. So it becomes 1/2, and this becomes x to the third divided by 3. And I'm going to do that from 0 to 2. So I can save the 1/2 for a minute and focus on what I get when I plug in 2 and subtract what I plug in 1. So plugging in 2 would give me 1/3 times 8. Again, plugging in 0 in this one gives me 0, but not always. So always make sure you know. So if you do 1/2 times 8/3, just a coincidence, we end up getting 4/3 again. So that would be our average value. And our last application is the moving average. So how you find moving average is, here's the definition. Let f be a continuous function over the interval a to b. The moving average function of f is given by this formula. So similar to the average function, but just a little different because we're going to have this L here, where L is the constant representing a fixed interval of time. So let's take a look and see how that would apply. Find the moving averages of the given function for the given values of x and the interval length L. So here's the equation they're giving us. They want us to look where x is 4, 6, 8, and 10. I'm not going to do all of this. I'll probably just pick one to show you an example, but you would do all of these if this was the problem. But for all of them, you'd be using the same L. So I'm just going to do one example. So let's just pick 6. If 6 was my x and 4 was my L, I'm just going to show you how you would find the moving average. So 1 over L, which is 4. The x I'm using is 6. So down here, I would do 6 minus 4, which is 2, because that's the x minus L part. of this function. So let's do it. The 1/4 I'll worry about later. I'm going to do the antiderivative. So I'm going to add 1 and divide by that. Add 1, divide by that. Add 1, divide by that. And the antiderivative of 1 would be x. And I'm going to plug in 6, see what I get, and subtract what I get when I plug in 2. So again, saving the 1/4 for the end. I'm going to plug in 6 to all of this. See what I get. Minus, plug in 2 to all of this. And then finally multiply by that 1/4. So all of this would give me 1315.2. All of this turns into 10.4. So subtract and multiply by 1/4, and you would get this. So if you're really answering this question, you would have first done this with 4 being the x, then 6, then 8, then 10. So it would give you 4 different values. And you could even use those 4 values to kind of graph what pattern is happening for this problem. But I just wanted to give you one example of using this equation. So that is moving average and average value and additive properties, which are all properties you can use now that you know how to do the definite integrals. So feel free to comment if you need any more examples done. Thank you.